In this video, we're going to talk about quadratic equations and some basic graphing of quadratic equations. We're going to start off with the most basic quadratic equation, y equals x squared, and we're going to graph this using a t-table. When we do a t-table, we start by picking values for x, plugging them into our function, and seeing what we get for y. So let's start off with x equals 0. If I plug in 0 for x, let's see, we need to square x in order to figure out what y is. So if I plug in 0 for x and square it, I find out that y equals 0. What that does for me is that gives me the coordinate 0, 0, which I can then plot on my coordinate plane. When x equals 1, I square that to find y, and I find that y also equals 1. Gives me the coordinates 1, 1, which I can plot on my coordinate plane. X equals 2, I square that to find that y equals 4. Gives me the point 2, 4 on my coordinate plane. I'm going to go through the rest of these a little bit quicker. When x is 3, y is 9. 5, 6, 7, 8, and that gives me that point right there. Now if you look at this, you'll notice that this is not a linear equation. In other words, when I graph this, this is not forming a straight line. So we're going to do a little more investigating. We're going to see what happens when x is negative. Let's see, x is negative 1. I square that to find y. Y is also going to be a positive 1. When x is negative 2, I square that to find y. Y is positive 4. When x is negative 3, y is positive 9. So I'm going to plot these coordinates, and then we're going to take a look and see what this graph looks like. Now, when you connect the lines here, when you connect these lattice points, you're going to connect them with a curve. It's a little lumpy, but it should be curved. And what this shape is, this U-shaped graph, we call it a parabola. And a parabola is the shape we get when we graph a quadratic function. So we're going to look at another one, very similar, except you'll notice this time we have a negative sign in front of my x squared. So when we're calculating y, it's going to be the opposite of whatever x squared is. Be careful with your order of operations here. We're only squaring the x. We're not squaring that negative sign. I'm going to go through these points fairly quickly. When x is 0, y is 0. When x is 1, I square that. That's 1, and then I take the opposite. That's negative 1. X is 2, I square that and take the opposite. That's going to be negative 4. X is 3, y is negative 9. Plotting that, we end up with, and I'm a little low on room, so I'm not going to do the 3, negative 9 here. But you'll notice that the parabola in this case is opening downward. Let me do the rest of the points. We're going to look at the negative side now. Negative 1, negative 1, negative 2, negative 4, negative 3, negative 9. And when I connect this, I have a parabola that opens downward. So, moral of the story here, when you graph a quadratic equation, you end up with a U-shaped graph that we call a parabola. If your leading coefficient is positive, in other words, here we really have a positive 1. If it's positive, your parabola is going to open up. If it's negative, your parabola is going to open down. Now let's talk about some parts of a parabola. We can have a parabola that has 2 x-intercepts. We can have a parabola that has 1 x-intercept, or we can have a parabola that has no x-intercepts. X-intercepts are what we refer to as roots. We also call them solutions. We also call them zeros. Lots of names for these things, but with any parabola, you might have two roots, or you might have just one root, or you might have no roots. Let's talk about the names of these a little bit. They are called x-intercepts because that is obviously where they intercept the x-axis. Right? Those are the points where they cross. They're called solutions because when we solve a quadratic equation and we get answers for x, say x equals 3 and x equals 5, those values, 3 and 5, would be the location on the x-axis where a parabola would cross it. We call them zeros. Let's stick with this example, x equals 3 and x equals 5. So let's say we solved the quadratic equation and got these two answers. We call them zeros because the actual coordinates are 3, 0 and 5, 0. In other words, y is 0, and we use that fact that when y equals 0, we're on the x-axis to see what x is. So let's look at an example where we talk about how to find the x-intercepts of the graph shown. Now if I look at this, I can see that this graph is a parabola that has two x-intercepts, or two roots. I notice my parabola is also opening downward, which means if I was going to write the equation for it, the leading coefficient would have to be negative. But the x-intercepts here are going to be 1, 0, and 3, 0. The x value is 1 when y is 0. The x value is also 3 when y is 0. Now we're going to actually solve, and we're going to solve two quadratic equations, and we're going to just do a rough sketch of what that graph is going to look like. We're going to solve these both using factoring. And remember, we're looking for roots, so we're looking for the zeros, so we're going to set y equal to 0. We're going to say 0 equals, now I'm going to factor this. This is going to be x, 3 and 1, plus and minus. And we're going to set each factor equal to 0 using the zero product property here. And we find that x equals negative 3. Which tells me that I have one of my roots right here at negative 3. We're going to set the other factor equal to 0. X minus 1 equals 0. X is positive 1. That's the location of another root. I notice that my leading coefficient is positive 1, and what that tells me is that my parabola is going to open upward. At this point, all I really care about is, do you know what roots are? And do you know which way your parabola should open? We're going to get much more detailed down the road, but for now, this is enough. Let's do another example. Again, we're setting y equal to 0 because we want to know where our x-intercepts are, or where our roots are going to be. So we're saying when y is 0, what's x? Well, I'm going to start by factoring out this negative sign. And I have 0 equals negative. Let's factor this. This is going to be x plus 3 and x plus 3. You'll notice that these are the same. When I set each factor equal to 0, whoops, let me switch colors here. When I set each factor equal to 0, I have x plus 3 equals 0, which means x equals negative 3, which gives me a root right here. If I was going to do the other factor equal to 0, it would actually be the same thing. I look at my original problem. My leading coefficient is negative 1. That tells me that my parabola is going to open downward, and it only has one root. So my parabola is going to look something like that. And that's going to do it for today. Thank you so much. Have a great day.